Hello! In this section, we are doing 3-4, the conditional and related statements. The conditional is fancy talk for your if-then. And symbolically, we would say P arrow Q, as we have in the top line there. Now, you can rearrange these if-then statements, and that can produce one of three of the following ones, as you see there: converse, inverse, and contrapositive. However, you have to be extraordinarily careful because only one of the three has the same truth value as the original statement. It is very common that, especially online, if you've ever been in, I don't know, a comment section of Facebook or wherever, people will take a statement and mix it up and convince themselves that it's true. No, it's not. So just be careful of that. So if anything you learn from this chapter, you'll learn how to battle trolls online. Hooray. Anyways, so our first one again is the if P then Q. That's what this first one says here. Oh, I need my pen. Pen. Boop. So that translates to if P then Q. It helps if I write the P. If P, then Q. Okay. Remember, to the left of the arrow is the premise, and to the right is the conclusion. So going back to our very first section, premise, conclusion. Okay. If you switch the premise and the conclusion, that creates what is called the converse. Q implies P. So let's do, you know what, let me make an example. If I eat an apple, then I will feel full. Okay, so that's the original statement. Let's do the converse now. I'll do that in this. I'll do it in purple. Purple. The converse would say, if I feel full, then I will eat an apple. Oops. Bink. So what I should have said before is, in the original statement, I eat an apple is our P. I will feel full is our Q. So by switching the P and the Q, we've created the converse. And now how about the inverse? I'll do that in red. Notice the inverse has the format not P implies not Q. So if not P will become if I do not eat an apple, then not Q will become then I will not feel full. So this goes back to an earlier section to where we were negating statements that occurred a couple times if I think about it. And lastly, we have the contrapositive. The contrapositive does two things. It flips and negates, meaning we flip the position of the P and the Q and then we negate each one. So not Q would be, and notice it's the premise now, so we start with the word if. If I will not feel full, or don't worry about semantics. If you want to say if I do not feel full, that's fine. Then not P will say then we can go past tense, did not eat an apple. Again, I'm not too concerned about semantics. Is the statement in the right location? In this case, did you also negate it? Great. Then you've completed the contrapositive. So again, original statement, if P, then Q. Converse, Q implies P. Inverse, not P implies not Q. Contrapositive, not Q implies not P. So flip, negate, flip and negate in that order is what it says. Okay. Now as far as truth value is concerned, you can create a truth table for all four of these. I will give you the good stuff. As it turns out, the original statement and the contrapositive have the same truth value. Meaning that if the original statement is determined to be true, then its contrapositive is also determined to be true. Likewise, if the original statement is determined to be false, then its contrapositive is also false. The original statement and the converse and inverse are not always going to be the same. As it turns out, this pair has the same truth value. But it's not going to match the other two. So be careful, again, when reading comments online, that pay attention to see if someone wrote a converse statement in their argument instead of the original statement. Because it's actually going to be called a fallacy, as you're going to learn later on. They created a fallacy, which is something false. The argument's invalid, blah, blah, blah. We don't want that at all. Okay, that is almost let me go to the next one. Yeah, that is almost the entire section. Let me pull up the videos. Yes, so in video number 40, you are given 3 statements and you're asked to find the converse, inverse, and contrapositive of all 3. So you're basically practicing this slide 3 different times. The first 2 have words, the third one has symbols. It's the same idea. Flip, negate, flip and negate. That's all you have to know. Now, as far as what a converse is, what an inverse is, what a contrapositive is, I will check, but I'm pretty sure that is given to you in that PDF on Blackboard as he slowly talks, as he clicks around. He's not wasting time. What are you talking about? Click. Yeah, they are there. So that stuff will be given to you on the test. You don't have to memorize them, just know how to use them, kind of deal. All right, so if you would, pause this one, go watch video 40, and come on back. So what we just did in the previous section was called the conditional if P then Q. Let me write that in words. If P then Q. That's the conditional. There's also the biconditional, which would be read P if and only if Q. So if you've ever heard the phrase if and only if, that is considered to be the biconditional. There's another way you can say if and only if. If P then Q, and if Q then P. We got an and there. What does and say? In order for an and to be true, both parts must be true, right? Okay, so let's add on to this left table here. Let's make Q implies P using these 2 columns. So remember, for the conditional, the order matters. So Q is this column and then P is this one. So true implies true is true. False implies true is true. True implies false is false. False implies false is true. So remember, for a conditional, the only thing that's bad is when true implies false. Otherwise, it's true. Okay. So now we're going to AND these two columns. And if we AND these two columns, boop, we'll create the biconditional. So true and true is true. False and true is false. True and false is false. True and true is true. So a biconditional is true if and only if both parts have the same truth value. So if they're both true or they're both false, then you'll get true. Any other case, like if there's a mix, then you get false. Ick. All right. Said that. So in video number 41, as he makes sure, click. Yeah. You're asked to determine if the following biconditional statements are true. So this is a quasi-short section because we already did a lot of the legwork in the last one. So if you would, please try video 41. That will conclude this section. Bing, bing, bing.